I have not worked for large companies, but I have developed 3 libraries, such as Alchemy, which is used for Jungle to link to. Today, we'll discuss small loads. High loads are very fashionable, but let us discuss small load today. Some people really manage to arrive at a level when users start coming to them for it. And then it is found out that to connect Django or some other request doesn't work. It works on the developer's PC, but when the very first clients come, it doesn't work. Well, certainly, when some people come to you for things, you need to simplify your products very strongly. Certainly, you developed the dependencies and you may have everything performing very well, but I am all in favor of simplification. And when people come, if it is up to 1 million requests per second, it's no Google at all. And if it is 1 million or 2 million requests per day, it is not a high load. It's just an average level project when people just started using it. But when it happens, people say, well, we have high load, we need to use Hadoop, or we need Cassandra, or I have heard about Kafka, whatever. OVS, AWS, we need to use all the products, and I could actually enumerate many others. But here's the basic thing to know. I thought for a long time whether I should put in a simple slide like this. In fact, it needs that we need first to learn the simplest things, such as N+1. And your project that you developed for developers' environment certainly has these problems occurring. However, we are not going to dwell in detail on N+1. I think all of you know about it. Do you know what it is? Overfetching is when you... Am I disappearing in your earphones? So overfetching is when you get complete recordings . Pink. We'll say pink. And then you might be getting more information than needed, and this is how GraphCredit was born. Maybe I should change my earphones. Pink. I'll be just like a rock star with a microphone now. And just to support my ideas, I will tell about a case study that we did for one of the projects. When we started dealing with real people, our task was that we had lots of data. It was clicks, it was business analytics, and they kept clicking everywhere, and we had lots of data from a lot of users. However, we didn't have too many clients, and we started developing problems after the very first 2 clients. And for a very simple reason, we gathered the data, we put them into the Postgres, and we could get out. Well, we have Google Analytics. If you want to get all the data from it, you would have to pay anything starting from $50,000 US. But if your startup is free, you cannot pay this amount. You cannot pay more than was invested in you. That's why Google Analytics makes it possible to get our CND mentions as a maximum, and we need some 20 of them. So you take them by 7. 7 in dimension, then 7 more, and so on and so forth. Then you write them into the database. The first 7, then the second 7. And what will happen if you use a Postgre? You rewrite each entry. That is to say, you get it out 3 times and then you rewrite it. Because in Postgre, the recordings are not changed but rather rewritten. That's why it works very poorly. However, it looks like I'm a developer without a PC. But however, we started with Postgres. We did a lot of things with those dimensions. First of all, we started developing problems because all the data from all the clients were put into the same table. But starting from a certain moment in time, Postgres we would always do secure scan because it would understand that you want too much. It has its statistics. So when you develop something for a minimal load, then you understand that Postgres has statistics. So it might decide based on the statistics that index will not help it. That's why the very first step is to divide the tables. It means that you will have identical tables, but it would be a separate table for each client. There are also groups of tables that could be used for groups of clients, but usually they perform quite poorly. And the system itself would not be able to create these tables for you. That's why it would be much simpler to divide the tables. It would be simpler and faster. This would immediately expedite the process by some 10 times. Then it's necessary to use aldjemy, SQLjemy. Here you get into the database, then you put down SQL, and then you can, in the same way, carry it over to SQLjemy, because it will repeat its semantics. And my project is intended for those who love jungle. It is called Nargin. Here is an illustration. It is a partitioner. That is to say, you write a function with a table which will create an object inside of itself. I seem to have lost where I need to be. We need to know our database very well in every detail. I have a lot of friends who can write things on Ruby, Rails, Concrete, and I use Go for this, and they said that we get lots of things from databases, then we put it into JSON, And the reason is quite simple. Once we get it from the database, then all the recordings are transformed into objects in the memory. Then we have a container, a class. We distribute them accurately, and after that we only send them to binary or text lines, and then we use a DBH collector, but all of it doesn't work. That is to say, we have evolution in place. First of all, it is JSON, then new JSON, which is really very fast, and if you have an error somewhere, you get a segmentation fault, and then you find out that you sent a wrong class object, even though it was fast. But then the final evolution is to generate JSON right inside the Postgre. What I mean is that we need to know our database, and we do not need to create anything. Or if it comes, then it would only delete one object. Here we have this code. We put down a simple helper, and then we put down select as JSON. If we have create query, create query with aldjemy, then JSON args will use a table, and on the top you can see various things to make it work. We need to prepare subquery, then adding alias and so on. But the basic code would look like this. You can see that there are actually some 20 lines, and new JSON is not required at all. And yet it is not good enough, because we still have Postgre. What is the standard solution to apply? What happens if you have 20 possible dimensions in various combinations and only 3 fields? What is the index to be based upon? You would always have secure scan. This would be the optimal strategy. If you always have SQ scan, then all kinds of databases, fixtures would not help you. Then what are we to try next? We need to put all the data together after classifying them, after sorting them. Our purpose was to calculate the number of unique users, and they have fixtures in the analytical data. To count them, you would need a big set to exactly count their number. The next task is to sort them, to screen them. If the ID is changed in your data, you add the +1. And in this case, you really save memory in a very good way. So you remember when we put it into the database, we had the problem that we could only add 7 of them at a time, and it didn't work very well. So I sent somebody to install hadoop. He left and never came back. And then, using Python, we need to make sure how it works. Python is really great for prototyping. Then we map the data. Then we use Ninky reduce. I will elaborate it now. How does it work? How does MapReduce work? Who knows how to do it? Who has implemented it? And who used the ready-made products? Any of you? Actually, MapReduce should have been called soft merge because it is its main portion. I don't want to tell you exactly what this code does. So we start with the sorting, and after we debug it, we get a key. Then we sort it, and we get, if it is the same key for the same items, it's okay. But then you can use globbyte. Has anybody here used it from Python? As a matter of fact, it appears semantically that once you get a list for it, it can easily group it, but it is not so. It only accepts sorted data from Apodux. I actually love reading Python-based models. ITIL tools is really quite a robust thing. And group by uses sorted data, and if there is one key, it will get the block back to you. And the reducer, well, we'll write the reducer ourselves. The reducer would simply receive the key. But then the main point about MapReduce is the sorted function. So once we get all the data, we send a query, then we map it, and we put it into a file. After that, we need to get all the files together. There is another file which is called heapq. Who has used it? Which of you have used the merge function with it? What does the merge thing do? You know that the sort function is used. It is really cool because it can be used just on a very simple PC. It cuts them into smaller files and then sorts them, and after that the sorted files are put together. That is to say, it merges the files in Python. In Python, the heapq merge receives already sorted. There is a second voice just repeating things after me, so you can then merge them. But we should also add a function here which will serve as a key. And thanks to this, we map them on the disk. They are already sorted. Then we send them to heapq merge, and at the outlet you will have a heap of files, so you do not spend any memory here. This is the very first case when iterators were really quite up to the mark. As I said, that's why sorting and merging are so important. They make them live. So now we have sorted them and have put them together. And well, indices do not help us. And now we take a new step. How can we put together the data? We have JSON. We have Basin. We have it from SmackDB, but the fact is that Basin would occupy more space, and running it would not be so fast. Then there are message pack. There are two very special things, such as cup and proto and flat buffers. You implement the data and you put them in this way. And when you are about to run them, you do not run them. You simply put a link there to a particular row. You do not create anything in the memory.
So I've got flat buffers. It has enjoys the support in the Python. That's how it is assembled. Serialization of the buffer is quite difficult because that's how the code looks like. You make a builders, like make a line, then I want the line to be the property of my object with all the lists, and that's how it looks like. The start list, finish, end list, but anything could be programmed. It's not a big deal. So I've got the files, I sorted them, and then I serialized the flat buffers, and I can handle the buffers with some other tools. It is such a tool as mmap. Who knows? Raise your hands. The same people. mmap is a system call of Unix. For example, you direct Unix. Here is a file, and it should be in the memory at this address. Unix tells you, fine. And so what's the trick? You are working with the memory. It's not just reading line and line and line, and whether the line should be in cache memory or not, but that's not the case. You just map it in the memory, and Linux will do the rest. The Linux has its own cache, and there is an address of the memory, and you choose the address, the core, and realizes that it has not got it, and it will then address the core. If the memory is needed, then all the pages with the file will be just cleared from the memory, because the core would realize that it could read it off from the disk. So when we use that kind of thing, and pretty simple in the Python, because it is very powerful language and it is very difficult to work. You just import map and everything is working. Here is the buffer. So it is the model is customer, and we just direct that that's the address for our model. And you can work with it right away. I have a disclaimer. Thanks to the files, flat buffers, and mmap, we write a thing that works much faster for this analytical case, much faster than PSG, and because PSG is just a universal, but over here we have the mmap into the memory, and it has got the syscalls working real fast, and then it takes it into some internal counters, and since all those files are sorted, so no need to memorize it, and the sorting is done by users, and it is done by +1, etc. Everything is fine with Python. It is a good language, but it won't be it won't be able to allocate memory without creating Pi object. It will have to work slowly, no matter whether we have PayPy or nums or whatever. We cannot overcome the essence of the language. It will have to create objects to work with them. It needs some kind of descriptions to have a shell. Python cannot work with clear int. It cannot do that. And now, switching over to such a thing as storage. I know this super productive storage, but it is only efficient to write. You can write real fast. You can have different data in it. There are like key value data. There are many applications for replications working just fine. And I can give you a list of tens. You can make snapshots, and this is a file system. A wrong slide. Or here is a case. We are still with analytics. So, for example, we might write a lot of data, then we can put it. The clicks in the flash pair on Mail.ru or where there might be millions per couple of seconds. Even if inserted then in the super distributed database, then even if it's a million of seconds, million of inserts per second, the database would collect. We will have a super fast depository, and we just write it in the files. And that the trick, the hype of using it on logs stands to reason, because if some of the cases are very cool in a large company, I used to work for Mail.ru, for example, I had such an experience. Over there, to write something real fast, you advance the low-level Unix core, and you know all the things over there. Like clicks from flash pair task was addressed in the following manner. We write everything into the file, and then we had a special processor to turn it into a binary format. There was MSSQL, and it can cope with a couple of millions per couple of seconds if the format was correct. And multi-million entries are installed, inserted right away in no time at all. So the recommendation that I have is to take this book and to read it thoroughly. Because in the long run, if you have a predicament, or if you become a Google, you need to know how your operating system would be working. You would learn about truncate, and there are many quite interesting nuances in Linux. Do you know how the memory works? Who knows what the setbrk is? Great! There are people who know what this is. How do you request the memory? Malloc, but in Python nobody calls anything. But if in any case you call malloc, call lock, etc., but these are not the functions of the core of Linux and not BSD. It is you work through setbrk, because the memory is virtual, and we just set that the memory is up to this cap, after this border, and to bring back the memory you will have to bring back to bring down the setbrk. So that's how the memory works. This here is a certain particular call that is handling the memory. Another thing, who has been developing the fork kit, or how exec really works. If you go down to syscall, then exec replace your software, your program with the other, but it's not intuitive, it's not user-friendly. The first fork is done, and there are two processes. The function is returned to you, like whether it is a parent or a child. Fine, then I execute exec, and I replace my code with the code of the program I wanted to have. Where were we? Here. Or another call, truncate. There are many tricks in the operating system, like truncate 2 gigabyte, and the operating system might say fine, but it would just mark a certain file as 10 megabytes, but it won't do anything. The operating system might do everything, and it will allocate the time when you will be writing. But in Linux there are many useful syscalls. For example, there's send file in nginx. What is send file? You open the file descriptor and you tell the operating system, like you send from this nginx to the socket. The operating system reads and sends. You don't have to do anything about it. And so you have to love syscalls of Linux. And Kirill did not tell you about DevOps, but let me tell you about it. As soon as you have the first production, you will have to write deploy in Ansible, or not necessarily in Ansible, but you don't have to do that manually. And another thing, if any of you is thinking of using Cuban Nets, it is fine. I can tell you from my own experience that Cuban Nets do work. And for those who are from the front end, if you do not read the latest recommendations of Google's and do not optimize your assets, I will hate you, because you will do a lot of work, but when you open the set and it keeps loading and loading and loading and loading, and then you will realize that that's a new Apex that is being uploaded. Here is another recommendation from Highload. You can load a separate table, for example, of all the users in a compressed manner. It could be 6. If you pack it, if you assemble it correctly, you can put 6 megabytes of memory. But since we are not Google, we will manage to do that, and it will be working fast. If you have data set in your memory, it will be working fine. And I also liked Taran tool, but I'm trying to recommend it, but I'm not quite successful in luring you into it. Another comment, it is not related to syscalls. when anybody tells us that we won't be able to do that because, like, look, we are not a bank, and some people were working. If the people were not working with the money, with no financial process at all, any financial organizations, they might lose money, and they can never write a system that never loses money. But you have to understand how much you can afford to lose. That's about it. Any questions? I saw 4 people who told me they know what syscall is. Kirill? Or Mikhail? Who is Kirill? Instead of loading the data into base, you load it into files, just like Google practices in the process. But who did it give it to? Because there are fragments, and not. It's one of the recommendations. Why do I have to tell you all? We had data, we mapped them, sorted them, and we have a serialized file, like analytics. It's a serialized large file. I put large files into it, with the flat buffer, and they were mapped, and then I wrote the program that can read them with the syscan. It maps them into memory and uses heap merge without queue, using heap merge, and it just moving through the database without knowing that there are many files. Like you instruct it to read it from a certain place, and then it gives you an answer, and then you save this answer. No, it's in JSON already, because it's not optimized, and the calls, the requests are different. And there's one cool thing, like if you instruct it to pack it with certain dimensions, and because twice the operation is repeated twice, because otherwise the indices will be so many. And what was that? And another thing. Hold on a minute. Just something that I recalled. It is possible to make 5 parallel groupings through one C scan, and it is possible to do that. It's not possible to do that though in the data with the database. What's the question again? If something happened to the machine, do you then load it again from the Google Analytics, or it never happened like that? The most important thing is to back up the database, and then loading it from the Google Analytics is no problem. And another thing, there's rsync, and you can launch it and save it at another server, and for this particular case it is more than enough, because those data are not unique. You will never be approached by the people like, where did you get my money to? Everything is still available in Google Analytics. Okay, thank you. recently we have ClickHouse. Why not use that kind of solutions? Did you try to compare it with something? ClickHouse, it emerged after I written my own. Why should I use ClickHouse if I have the thing? And but it cannot do work in parallel. And another thing, anything tells you to use hyperlock. Let me explain you what it is. Like, how can you calculate how many users you have? Let's imagine you have a heap of IDs and you want to calculate how many these are. What methods are used? You make a large map, like a hash map. You save all the IDs in it, and then you can calculate those. Then another option is to take all the data, to sort those, and then to calculate it. It's not that fast. So what are the other options? What are the other people suggest? We won't take all the data. We'll take 10%. We'll calculate, like for 10,000 of entries, we have 10, and so, but it is the rule of the thumb. The ClickHouse can propose it. Like, if I request the ClickHouse to do, say, unique users, the ClickHouse is not willing to do that, sort of. But people need that kind of information, and hyperlock might be using well, but I've been testing it on mine, and it was just by the rule of the thumb. It didn't suit us. True, it is too empirical. It's not accurate. It is very vague. So, because they do not very meticulous about sorting and etc. to get the accurate number, not them. And by the way, another thing, it is possible to calculate the users in parallel, because all of them are sorted out. What about the efficiency of using the time of the developer? Isn't it better to make the small data framework and then use paste part? But who will build the Spark for us? Who can do it for us? That's question number one. And another, how much time might be used for using Spark? And then on the other thing, objectively it will be working slower than in the memory, because there are many problems with the Spark. Either the memory is not enough, is sufficient, and I had the 3 developers only. One was junior, another was senior, and the other was me. How Cook would be doing it? It is just using the experience of the previous developers. Yes, but you have to still spend a lot of time to develop, to build Spark, because yeah, I sent my person to build hadoop. He was gone, and he never came back. And when I started to use hadoop, and I wanted to put them, and the files were small, and then I realized that Hadoop has special files to put the small files, but what of those 10 I will have to use? So no, Spark is no good. Or let us take the experience of our big brothers from Mail. Like they say Hadoop, and they will rewrite it. But me, I do not have that many developers. I'm not prepared to rewrite Hadoop, because with them, if they need a certain case, they will rewrite Hadoop, but they have so many developers. What do you mean by rewriting Hadoop? Well, adapting it, customizing it, and they have customized it. Anyway, but it is difficult to customize Hadoop, and at least not with my team, where I have only 3 persons, limited. But there is such a thing as customer development, like you do not know what you will sell. You develop a certain feature, and you just do not have time to sit tight, to build the hierarchy of classes. No, you cannot earn money like that. You have to move fast. Anyway, they're motioning me off the floor.